Hello everyone, this is the Algebra 1 video. This is for lesson 10.1. What we're going to be doing is we're going to be going over the examples that are presented in the textbook. Now, you should start off by heading to page 408. If you're not there yet, please do so. Also, at any point, if you feel like you need to pause, rewind, fast forward, I highly recommend you do so. I also recommend that you take any necessary notes that you think you would need for this lesson. But one more other thing, this is an iPad that I am writing on. If I do get some random notifications, I do apologize. Sometimes my emails and text messages kind of come through and they might show up on the screen. I do apologize in advance if that's going to happen. But what we're going to do now is we are going to focus on just lesson 10.4 since we didn't get to cover it during class on Zoom yesterday. And if you notice, the title of this lesson is actually all about dividing radicals, right? So if you take a look here at example 1 in a moment, you'll see that all of these that we're about to do are dividing. Lesson 10.3, not 10.4, but 10.3 was all about multiplying. This one's all about dividing. Now, I wrote something here and I highlighted in yellow. This is going to be the main theme of the lesson, of this entire lesson, is I cannot have a radical in the denominator. I repeat, you cannot have a radical in the denominator. Dividing something with a radical is going to get you a really long number, even if you type it in on your calculator. And even on some calculators, it might say error. So there is a proper way of dividing radicals, and you do need to make sure at all times that you cannot have a radical in the denominator. So we're going to start off by working on example 1. And as you can see here, it says radical 3 divided by radical 6. So what I'm going to actually do is every single time you have it laid out like this, you should really write it more like a fraction. I know kind of doesn't make sense. Maybe for some of you, you're like, I don't like fractions, that's less attractive. But that's what you want to do. And this is what you're going to more commonly see, okay? So what I'm going to do is I'm going to rewrite it over here. And you're going to notice, hey, wait a minute, you just said at the very top you can't have a radical in the denominator. So there is a way to get rid of this, right? You can't just divide 3 and 6. There's multiple ways of doing this. I'm going to start off by doing it the way that the textbook does it, and then I'm going to do it the way that you're going to more commonly see more and more and more. So one thing is that when both of these have a radical, that means the whole thing has a radical, okay? That means the whole thing has a radical. And if you notice this as a fraction, you might be able to simplify this. So let's simplify this whole radical and the fraction that's inside. Instead of 3 over 6, we're going to have 1/2. Now here's the problem. 1/2 means radical 1 over radical 2. This is still a problem. You still have a radical in the denominator, right? So how do I get rid of this? You need to get rid of that radical, okay? And I'm going to highlight it here. This is going to be very important. I'm going to highlight it in orange. To get rid of that radical 2, you actually need to multiply the bottom with itself and at the very top. So I'm going to do radical 2 times radical 2, and then whatever I do to the bottom, I'm going to copy it to the top, okay? This is how I best get rid of the radicals, okay? So once again, I'm going to multiply my denominator with itself, but also multiply it with the numerator. Let's see what we get, okay? Well, radical 2 times radical 2, when we multiply it, that is radical 4. And then radical 1 times radical 2 is radical 2. Now take a look at what's going to happen. You're probably wondering, there's still a radical at the bottom. Well, I'm going to rewrite it over here. Well, actually, can't you actually get the square root of 4? You sure can. The square root of 4 is 2. And at the top, it's the square root of 2. And you know what? This is actually your final answer. I'm going to highlight it in red. This is your final answer. So you're probably wondering, I didn't really do any dividing. You're right, you kind of didn't. It was just more like simplifying. And you're going to notice that throughout your homework, it's going to say simplify instead of divide. Okay? So that's one important thing that you need to know. Also, if you notice, you don't have a radical there at the bottom. Uh, so that means you are a-okay with leaving it like that. It's okay to have a radical at the top. You just cannot, as I mentioned above, highlighted in yellow, cannot have a radical in the denominator, okay? So let's keep going. I'm going to go on to example 2. Okay, this is still on the same page, page 408. And this time the directions say simplify. See how it says simplify? Even though simplify and kind of divide mean the same thing. And it says the square root of 3 over the square root of 12. Now, automatically you notice, hey, maybe I can put this all as one big fraction as 3 over 12. Remember, having two individual radicals, okay, is the same thing as putting it all under one big radical, okay? And if we can simplify it, let's simplify it. Simplifying 3 over 12 would get you 1 over 4. And now what we're going to do is we're going to make them go back to its own individual radicals. What I'm going to do here now is see if I really need to multiply with the denominator. So here, in the first one, example 1, I multiplied by radical 2 because I couldn't get the square root of 2. When you type in the square root of 2, you're going to get kind of a really long decimal. But here, can I actually get the square root of 4? Think about that for a second. You sure can. The square root of 4 is 2. And can you actually get the square root of 1? Yeah, you can. The square root of 1 is 1. And your answer is 1/2. So if you notice, all is well. Both of my answers for example 1 and 2 were both fractions, and that's okay. You just need to make sure that at the very end, you cannot have a radical in the denominator, okay? So we're going to keep going. And like I said, if you ever get confused or lost, please feel free to rewind, fast forward, pause during certain spots. But right now what we're going to do is we're going to do example 3. It's going to get a little bit interesting. And again, it says simplify. And we are going to simplify the square root of 2 over the square root of 75. Okay? Now, here's the interesting thing. What I've been doing for each one of these in the beginning is putting two radicals, right, into one big radical, just like how I did in example 2, just like how I did in example 1. Let's kind of take a look at if I do that, what's going to happen. So if you notice, square root of 2 and 75, here's the problem. Can that really simplify? For these other ones, they were able to simplify, but for this example, you can't really simplify. So we're actually just going to kind of leave it back to how it was. And you're probably wondering, why in the world would I do that? Well, here's the thing. You kind of want to now do what you did earlier, back in example 1. If you have a radical in the bottom, multiply it with itself. Do I have a radical at the bottom? I sure do. So I'm going to multiply it with itself. And what I do at the bottom, you do at the top. And I have some really interesting news. You're probably wondering, oh boy, I have to do 75 times 75. You can do 75 times 75, but I have some even better news. You do get to use a calculator, of course. But fun fact, I'm going to put a little side note, and I'm going to put it actually back in example 1 to show you something, okay? Back in example 1, when we worked it out, right, I'm going to put it in green, we did square root of 2 times the square root of 2, and our final answer gave us a denominator of 2. You see that right there? So actually, here's a side note that you can always write down. When you get the square root of the same number and you multiply it with itself, see if I make some space here. Actually, I'll put it back. I'll put it in an example 3. I'll put this as the side note here. This is my side note here for example 3. When you get the square root of the same number, something like the square root of 6 times the square root of 6, your answer is just 6. This works for any number, as long as it's the same number. If I did the square root of 5 times the square root of 5, my answer is 5. If I did the square root of heart times the square root of heart, my answer is heart, okay? Without the square root at the end, obviously. So be mindful, every time you get the square root of a number, multiply it with that same square root of the number. It's just the number itself. Why is this good news? Well, you maybe don't want to do the square root of 75 times the square root of 75. But because they're the same number, you know this is going to be 75. So that's something to look forward to, okay? Now back up here, these are not the same numbers, so those I really do got to multiply. And 2 times the square root of 75 is the square root of 150. And you're probably wondering, yay, I'm done. Unfortunately, you are not done. There's a little bit more that we have to do. We didn't have to do it in examples 1 and 2, but you do need to definitely do it. Now, if you notice, the directions at the very top say to simplify, okay? So that means there's a little bit more to this. You do need to make sure that you are simplifying anything that has a radical. Mrs. Elliott, how do we simplify a radical? Well, let's remind you again. We're going to focus on that square root of 150, and I'm going to focus on this. I'm going to put this in a blue color. Let's go back to what we did back in Tuesday's class yesterday, right? How do we simplify a radical? Well, remember, we want to break this down and use a little factor tree. So for example, I can use 15 and 10. I have 3 and 5 and 2 and 5. And remember, any pairs, right, go on the outside of your radical. So let me put that there. My pair was 5. And everything that wasn't a pair gets multiplied and goes back inside. So 3 times 2 is 6. So really, my numerator is not the square root of 150. My numerator is 5 square root of 50 over 75. Okay? Again, if you get confused, rewind, fast forward, pause. But all I did was I simplified the numerator, or broke down the numerator even more. If you have that blue calculator called the TI-30XS, it automatically does this for you. So that would be good for you, okay? Otherwise, here's what you need to do. You got to keep going because this is actually not the final answer. You want to make sure that you simplify this fraction. For example, is there a number that goes into 5 and 75? There sure is. 5, right? If I divide this by 5 and I divide this by 5, let's see what we actually get. 5 divided by 5 is 1, and 5 divided by 75 is 15. So my full and final answer is 1 square root of 16 over 15, and that's it. Now, if you don't want to put the 1 in front of the radical, you don't have to. You can just write square root of 6 over 15, okay? And that is, either one of these are the correct answer, all right? We are on to number 4. It does get a little bit more advanced, but good news is not that much advanced. Here's what I mean. We are going to do example 5 on your printed notes. I mean, in your textbook, excuse me. Here's example 5. And this is actually on a new page. This is on page 409. Okay? And it says, again, simplify, but what are we simplifying? It wants us to simplify the square root of 18a squared bc3 divided by 9ab3c2. Now, we don't want to write it out like this. Remember, we kind of want to write this out as a fraction. So that's what I'm going to do. I'm going to write this out as a fraction, writing the first one at the top, the second one at the bottom. And then before we even start, we want to make sure if there's a radical on both, we put it all under one radical. So 18a squared bc3 all over 9ab3c2. Okay? From here, you want to make sure if you can simplify. We're going to start off with the numbers itself, so work your way. Don't panic that there's numbers and letters. We're going to work on just the numbers, 18 and 9. Well, yeah, I can definitely simplify 18 and 9. I get 2 over 1. And then you want to do the same thing. Now, if you don't want to put 2 over 1, you could just put 2 at the top, but I'm going to put it as 2 over 1. Now you want to do the same thing, but with the letters, A2 and A. Remember, back in our exponents rules that we learned a while back, okay, I'm going to put it here in purple. This actually means that you are subtracting A2 minus that 1 that's at the bottom. That's what it really means, okay? So I'm going to subtract 2 minus 1, and that gets me A1. Now I put it at the top because my bigger number is at the top. I can do the same thing here with my b's. I can subtract 3 and that little hidden 1 that's there, okay? And I would get b2. However, because the bigger number is at the bottom, b2 is at the bottom. And the last one, okay, is my c3 and c2. And when I subtract those, I get C, and it's at the top because the bigger exponent is at the top. Now, I don't need to put A1 and C1. I could just put A and C. And what I want to do now is, now that I have this out, I'm going to rewrite it over here. Okay. I'm running kind of out of space. 2AC all over 1b squared. Now, if you don't want to put a 1 in the front, you don't have to. You can just put b squared. And just like what we did is with all these examples, like in examples 1 and 2 and 3, every time I have one big radical, we can put it into 2 separate radicals. So that's what I'm going to do here now for example 5. I'm going to put it into 2 separate radicals, 2ac over the square root of b squared. And then I have some really awesome news. You don't need to multiply with itself. Here's why. So some fun facts. Anything that's to the, I'm going to put it in purple again over here. Any number that is being squared, and as long as it's in the radical, is just the number itself. And that's because squared and radical cancel each other out. So same thing is going to happen here. That square and that radical are going to cancel each other out. I'm just left with the letter B. And at the top, I have 2 square root of 2ac. And this right here, everybody, is my final answer. I'm going to highlight it in red. Okay? Now, why is this my final answer? Going back to what we said all the way at the top, we just can't have a radical in the denominator, but it just doesn't, I never mentioned anything about having a radical in the numerator. I forgot to highlight this one. That was the answer for that one. But I can have a radical at the top. I just can't have a radical in the bottom. Now let's try to do one more. We are going to do our final example, which is example 6, and this one is also on a different page, okay? So this is the very last one. This is example 6, and this is on page 410. And again, the directions say simplify, and then they give you this radical fraction, which actually means division. They give you this 3x to the third. I'm hoping, yes, I am reading that right. X to the third over 4 square root of x 5y. All right, so I'm going to start writing some things here in brown. And the reason why I'm going to write some things here in brown is because this is not the correct way of doing this. Now, every single time that we've been starting these other examples, I've been telling you to put it under one big radical. Unfortunately, for this particular case, you can't do that because if I have a number outside the radical, that's when, how can you put something like the number 4 inside when it originally is outside? Okay, so you don't need to write that. What do I do instead? Well, the best way to go about this is if you have a number outside the radical, but you have a radical in the denominator, and remember, as mentioned all the way in the beginning, you can't have a radical in the denominator. What should you do then, right? Well, you get rid of it by multiplying it with itself. So what I do to the bottom, right? That same radical, we're going to copy it. And what I do to the bottom, I'm going to do to the top. Now you're probably wondering, what do I get at the bottom then? Well, I have this 4 on the outside. We're just going to stick the 4 there. And then this, remember, when a number repeats itself, let's kind of go back to that other clue that I gave you in purple here. When you have, I'm going to laser point it up in this corner in the purple. When you have a radical of something and you're multiplying it with the same exact value, it's just that itself. It's just the number or variable itself. So these are exactly the same. X5, X5, they're both in the radical. So guess what? It's just X5 and Y are both in the radical being multiplied. They're exactly the same. So it's just Y. Now the numerator, we do need to actually multiply because they are very different. There's 3 and times 1, which is 3. And this is still in the radical. X3 and X5 is X8. And Y is by itself. Now I am almost done. We just need to make sure of one thing. Just like how I did in example 3, it says here to simplify. I underlined it in orange. Always make sure if you can simplify your numerator. So we are going to check now if we can simplify this numerator. As we mentioned in class, right? I'm going to do this in blue here. We want to see if we can break down the number, which I only have 1 and 3, so not really. However, I can definitely break down that 8x. That 8x means, whew, there's a lot of 8s. It basically means, I'm not even going to draw all these arrows. It basically means x times x times x times x times x times x. 1, 2, 3, 4, 5, 6, 7, 8 x's. And we want to pair them up in groups of 2's. So ready? 1, 2, 3, 4. How many groups of 2 do we have? We have 4 groups of 2's, and those are my x values. And then y is just y, so that there's no pair there. So everything that doesn't have a pair, remember, goes back inside. Okay? So that is my numerator, and I'm going to rewrite it over here. X4, 3y, all over 4x, 5 to the y. I notice that these two guys right here can definitely be divided, or in other words, subtracted. And when I do that, I get my final answer as 3y over 4xy. Okay? And that is your final answer because you can't simplify the numerator. There's not much, we simplified any monomials that are alike. But this is how you basically do lesson 10.4. If you have any questions, please feel free to email me. But like I mentioned previously, please rewind, fast forward, take notes, even go through the textbook, or there are some really great examples on the printed notes as well. I hope this helped each and every one of you a lot. Have a great day.